Ladies and gentlemen, if my electric current kills, then I deserve to be its victim myself.
Nikola Tesla was an innovative Serbian-American inventor.
Where I constructed a unique mechanical oscillator. I could destroy the Brooklyn Bridge in a couple of minutes. That's what selective resonance means.
And some of his inventions were insane.
I was able to transmit an electric charge wirelessly across the ground.
Join us as we look at 20 of the scariest inventions by Nikola Tesla that were hidden from us.
Definitely my favorite project is this Tesla gun. That produces about 400 volts.
20. Nikola Tesla. Never in human history has a man been so both revered and reviled as Nikola Tesla. The brilliant inventor, who is credited with groundbreaking discoveries such as the remote control and alternating current, was also well known for his bizarre ideas and strange inventions. Failures, disappointments, financial difficulties, emotional breakdowns, and separation from the rest of the scientific world hampered his progress. Nikola Tesla became an inspiration for many scientists who refused to be boxed in after his death. His insane ideas continue to ring true in the hearts of many people who, like him, choose to go beyond the stars and are not afraid to show the world the fruits of their imagination. The Serbian-American inventor's reputation is often connected with his contributions to the development of alternating current electricity. 19. AC motor. In our thumbnail, Tesla seems to be holding a crystal ball and definitely looks like a magician, which, in truth, he actually was, in his own way. Tesla invented a technique for generating electrical current in a piece of iron spinning between two electrified wire coils. When this spinning magnetic field device was rotated using mechanical energy, such as steam or hydropower, it generated alternating current. When the generated current reached its user and was fed into another rotating magnetic field device, it transformed into an AC induction motor that generated mechanical energy. Induction motors powered domestic appliances, such as washers and dryers. The invention of these devices resulted in widespread industrial and manufacturing applications for electricity. Tesla's overall vision included more than just the induction motor. He exhibited a polyphase alternating current system, including a generator, transformers, transmission scheme, and motor and lighting in a series of patents that made history. It offered the basic ingredients for electrical production and usage from the power source to the power user. Today, our alternating current power grid is virtually unchanged. 18. Tesla ether propeller. In the 19th century, physicists' understanding of the ether shifted considerably. New breakthroughs in thermodynamics, energy physics, electricity, and magnetism influenced the ether's properties. These have generally been explored via the lens of scientists reconceptualizing the ether. Nikola Tesla, a successful inventor and writer, gave a new view of 19th century physics. Along with the exhibits showcasing his innovations, he gave different interpretations of physical, physiological, and even psychic studies. This is particularly visible in his telautomaton, which is a radio-controlled boat. This innovation, and Tesla's descriptions of it, demonstrate some of his innovative interpretations of physical theory. He provided a perspective on 19th century physics that emphasized practical application rather than experimentation. Tesla's mastery of physical theories was sometimes harmful to his own imaginative work, but he sometimes provided new insights. Tesla's utilitarian understanding of physical ideas implies that the inventor was more scientifically curious and invested than previously thought. 17. Tesla elevator. Tesla filed a patent in 1928 for a vertical takeoff machine with a tilt-wing rotor, which was both stunningly predictive and maddeningly naive. This V-22 Osprey prototype was to be propelled by a turbine engine, which was much beyond the state-of-the-art in the 1920s. Although the airplane portions of its design were fair, the rotary wing aspects were not as outstanding. Torque was effectively balanced out by rotating the lift rotor's propellers in opposite directions. However, it is unclear how the aircraft would have been handled in vertical flight, and the rotors were plainly far too small to support the machine in that configuration. Nonetheless, this was the first known iteration of the tilt rotor concept to be patented, and as such, was the precursor of all those bizarre 50s VTOL prototypes that never worked properly but looked amazing before they crashed somewhere. 16. Tesla Earth Battery. Tesla's long-held aim was to generate an infinite supply of pure energy that was free for all. He was staunchly opposed to centralized coal-fired power plants that emitted carbon dioxide into the air we breathe. He claimed the Earth held fluid electrical charges beneath its surface that, when disrupted by a series of electrical discharges at regular intervals, would provide an infinite power supply in the form of enormous low-frequency electrical waves. One of Tesla's most remarkable experiments was to carry electrical power across large distances without the use of wires or cables, a feat that has remained a mystery to scientists ever since. His aim was to free humanity from the burdens of collecting, pumping, transporting, and burning fossil fuels, which he saw as sinful waste. Tesla was eventually undone by what he described as ignorant, unimaginative people consumed by self-interest, powerful guys who tried to maintain the hugely profitable, low-tech industries they had spent their entire lives developing. 15. Tesla heat ray. Nikola Tesla was in financial trouble by the 1930s. The once prodigious genius who had revolutionized the globe with his electrical innovations was now a frail old man trudging between Manhattan hotels, stockpiling newspapers, and birdseed. When the unpaid bills at one hotel were too much for him, he'd just move on to the next, his fading renown being his only currency. People took notice when Tesla began talking about even crazier projects, such as a powerful new weapon he was developing. Tesla said that his new weapon would use a beam of metal ions traveling at 270,000 miles per hour. He was always vague about how this beam was feasible, claiming new laws of physics that no one had ever imagined. Nonetheless, he boasted to every reporter who would listen about his work. The all-penetrating beam would pack 100 billion watts into just 100 millionth of a square centimeter. For decades, Tesla hyped his Teleforce weapon, claiming it could shoot down planes from 250 kilometers away. The innovation was given a new name by the press, death ray. Tesla, despite claims to the contrary, never offered much evidence that the death ray operated, but no one could completely ignore the possibility. This was, after all, Tesla. The weapon's popularity skyrocketed in the run-up to World War II, as Nazi Germany created a fearsome air force. People in Tesla's birthplace, then known as Yugoslavia, asked him to return and install the rays to defend them from the Nazi threat. This never materialized, even though Tesla continued to claim he had invented the death ray until his death. 14. Tesla laser. Tesla had really gotten a patent for his wacky idea of using lasers to wipe trash off vehicles, a car cleaning system which consisted of a beam optics assembly that emitted a laser beam to irradiate a zone on a vehicle's glass, debris detection circuitry that detected debris gathered across the region, and control circuitry. The control circuitry calibrated a set of parameters associated with the laser beam emitted from the beam optics assembly based on detection of the debris accumulated over the region on the glass article. It controlled the exposure level of the laser beam on the debris, accumulated based on calibration of the set of parameters associated with the laser beam, wherein the exposure level was regulated by pulsing the laser beam at a calibrated rate that limited the laser beam's penetration to a depth smaller than the thickness of the glass article and eliminated debris accumulated across the region on the glass article with the laser beam. 13. Tesla musical resonator. The singing Tesla coil, also known as a sousaphone, theremin, or musical lightning, is a type of plasma speaker. It is a type of solid-state Tesla coil that has been developed to produce musical tones by regulating the spark output. The resulting pitch is a low-fidelity square wave that sounds like an analog synthesizer. The high-frequency signal serves as a carrier wave. Its frequency is substantially higher than human audible sound frequencies, allowing digital modulation to produce a recognized pitch. The musical tone is produced directly by the passage of the spark through the air. Solid-state coil drivers are limited to on-off modulation, hence the sound generated is square-like rather than sinusoidal. Early versions of musical Tesla coils typically used zero-crossing threshold detectors to generate music via their spark output. An example of this circuit was released by CTC Labs in 2009. Scott Coppersmith was the first person to create a comprehensive MIDI-controlled Tesla coil system. MIDI is the most popular way to produce music. It uses a microcontroller that is configured to interpret MIDI data and generate a corresponding pulse-width modulation signal. This PWM signal is transmitted to the Tesla coil via a fiber optic cable and controls when it turns on and off. 12. Tesla solar power. Nikola Tesla predicted the existence of the ionosphere, an electrically charged layer of the atmosphere, years before it was discovered. Tesla's first radiant energy receiver was essentially an early prototype of a solar energy panel. Tesla was the first scientist to find radiant energy. He observed how the sun served as a source of kinetic energy. Tesla intended to condense the energy trapped between the Earth and its upper atmosphere and convert it into an electric current. Nikola Tesla used to work for Edison. According to records, at one time during his tenure, Edison offered Tesla $50,000 for for an improved design for his DC dynamos. After months of experimentation and sleepless nights with his crew, Tesla proposed a solution. He asked Edison for the money, and Edison declined, claiming that Tesla did not understand American humor. Tesla left shortly after and established a competing lab in Lower Manhattan, directly across the street from Edison's New York factory. Tesla's lack of commercial understanding possibly cost him a more ordained legacy, such as Thomas Edison's. He was a scientist, not a businessman. Tesla envisioned a system of permanency in which society might meet its needs and show its full potential in the present, while maintaining biodiversity and natural ecosystems, in an era when ruthless industry and capitalism dominated innovation. 11. Tesla, bladeless turbine. Nikola Tesla designed the Tesla turbine, a bladeless centripetal flow turbine, in 1913. Nozzles directed a moving fluid onto the edges of a series of discs. The engine generated rotational movement by rotating smooth discs in a chamber by the exchange of momentum between the fluid and the discs. The discs were placed in a manner like a stack of CDs on a pole. The Tesla turbine employed the boundary layer effect rather than the mechanism utilized by more traditional turbines, which involved a fluid acting on blades. The Tesla turbine was also known as a bladeless turbine, boundary layer turbine, cohesion-type turbine, or Prandtl layer turbine. The latter was named after Ludwig Prandtl. Bioengineering experts also referred to the Tesla turbine as a multi-disc centrifugal pump. Tesla intended to use this turbine to generate geothermal power, as was outlined in his article, Our Future Motive Power. 10. Tesla robot. Tesla sought an innovative approach to illustrate his system's potential for wireless energy transmission. In 1898, he displayed the world's first radio-controlled vessel at an electrical exposition in Madison Square Garden, which had recently been completed. Everyone expected surprises from Tesla, but few expected to see a small, odd-looking, iron-hulled boat scooting across an indoor pond. Tesla described the boat as having a borrowed mind. Some believed Tesla was operating the miniature ship with his thoughts in an era when only a few people were aware of radio waves. In fact, he was sending signals to the mechanism via a little box with control levers on the side. The functional device, known as a teleautomaton, responded to radio signals and was powered by an internal battery. Tesla did not confine his technology to boats, but rather expanded the invention's potential to incorporate all types of vehicles and machinery that might be activated for any purpose. He imagined one or several operators simultaneously directing 50 or 100 vessels or machinery using differently tuned radio transmitters and receivers. When a New York Times journalist recommended that Tesla submerge the boat and use explosives as a weapon of war, the inventor exploded. Tesla's gadget was practically the beginning of robotics, but he is rarely recognized for this achievement. The creator was skilled in electrical and mechanical engineering, and these talents came together brilliantly in this remote-controlled boat. Unfortunately, the invention was so far ahead of its time that many who witnessed it were unable to envision its practical implications. While Tesla did not invent robots in the contemporary sense, he was a pioneer in the field of automatons, which are mechanical machines that can perform tasks on their own. Tesla's work paved the way for eventual advances in robotics and remote control. His ideas were ahead of their time, and while he did not create robots as we know them today, his teleautomation was a significant step forward in the evolution of robotic technology. 9. Phosphorescent bulb. Tesla's early lighting inventions were traditional filament or arc devices that were powered by high-frequency currents. As he immediately discovered, such currents could be used to diffuse gases or generate light emission in many solid materials. His ideas in this sector, while influential and revealed in a series of acclaimed lectures, were rarely patented. Because Tesla invented more powerful gear that could function at greater frequencies and voltages than anyone else, he was able to generate fields that could light up phosphorescent tubes throughout his laboratory without the use of wires by 1890. The energy was simply long wavelength radio from Tesla's high-frequency generators, but the signal was strong enough to be usable as power rather than communication. His early wireless power demonstrations, delivered with consummate flair, had the electrical profession transfixed, and the people who were exposed to these mysteries at Tesla's lighting show at the 1893 Columbian Exposition came away with the notion that a new era of scientific miracles was on the horizon. 8. Tesla gun. The Tesla gun is a completely self-contained portable lightning machine made of a backpack with battery storage, CPU, and power supply circuits, and a pistol grip-mounted Tesla coil capable of producing approximately 6-foot spark lengths. The power supply circuitry is water-cooled and can operate continuously for several minutes or intermittently for several hours. The advanced control circuitry allows the gun's sparks to be changed in duration, frequency, and pulse rate. The gun can be used to ignite hydrogen-filled balloons for a loud bang, or it can be pointed at a grounded rod to roast marshmallows or hot dogs. At lesser power levels, the sparks aren't hurtful, and those bold enough can even touch them. 7. Tesla flying machine. Tesla began merging his expertise of electrical and mechanical engineering to apply it to flying. After Wardenclyffe's failure, he needed something else to occupy his thoughts. What better than the idea of flight, which had fascinated him since he was a child? In the July 1919 issue of Reconstruction magazine, he described his work on constructing a supersonic aircraft that would go 8 miles above the Earth's surface and create enough speed for passengers to travel between New York and London in 3 hours. His idea was to use electricity transferred wirelessly from power plants on the ground to power airplanes, removing the need for aircraft to carry fuel. 6. The Wardenclyffe Tower. Tesla was widely considered as America's best electrical engineer by 1900, having captivated the globe with his breakthrough innovations and victory over Thomas Edison in the Battle of Currents. He then began his most ambitious project to date, the Wardenclyffe Transmission Tower. The Wardenclyffe facility, built between 1901 and 1905, was based on another of Tesla's groundbreaking concepts. Tesla intended to use the tower to achieve what had previously been thought to be impossible, a global, wireless communication system. The tower would be the prototype for a system that would use the Earth as a conductor to broadcast music, news, stock market reports, secure military communications, and even facsimile images around the world. It was an extremely foresighted attempt to build a telecommunications infrastructure comparable to what the internet provides today, but entirely wireless. But Tesla had a far more ambitious plan for the huge Wardenclyffe Tower. He had already demonstrated that high-frequency signals could be carried wirelessly using his own Tesla coil transformers, which led to what would become a lifelong obsession: wireless energy transmission. Unfortunately, Tesla's lofty ambition for Wardenclyffe outstripped his means and the patience of his sponsors. The project fell into financial difficulties before completion, and the unfinished tower was finally dismantled in 1917 to satisfy Tesla's obligations. What was once a renowned laboratory full of fantastic Tesla innovations is now a desolate memorial to his most ambitious idea. 5. Earthquake generator. Tesla was working on waves and resonance for energy transfer in 1896. The plan was to build a mechanical oscillator capable of producing various frequencies until they matched the resonance frequency of the desired object. The gadget was completed in 1897, and in 1898, he allegedly managed to oscillate his laboratory at 48 East Houston Street, New York, to the point where worried neighbors phoned the police and an ambulance, fearing an earthquake. He put his small vibrator in his coat pocket and headed out to look for a half-built steel structure. He discovered 10 floors of steel framework with no masonry or stone laid around it in the Wall Street neighborhood. He attached the vibrator to one of the beams and fiddled with the settings until he was satisfied. The structure began to groan and weave, and the steel workers rushed to the ground, terrified that there had been an earthquake. The police were called. Tesla slipped the vibrator into his pocket and walked away. He could have laid the building on the street in 10 minutes. In fact, modern seismology uses vibrations produced by controlled explosions or mechanical pistons as a type of underground echo sounding to prospect. Nobody, however, possesses an earthquake machine to this day. 4. The thoughtography. Tesla felt that thoughts could be photographed. In 1893, he was inspired while conducting tests. He felt convinced that a definite image generated in thinking must, because of reflex action, produce a similar image on the retina, which might perhaps be read by appropriate apparatus. The creator imagined reflecting an image on an artificial retina, photographing it, and presenting it on a screen. If this were to be accomplished, the items envisioned by a person would be plainly reflected on the screen as they were created, allowing every thought of the individual to be read. In the year 2023, scientists are researching techniques to read human thoughts. There is also a new initiative that uses AI to help decipher what our neurons are doing, so it can transform it into writing. Not precisely what Tesla had in mind, but not that far off. Even more technological trickery may be feasible in the future, such as the ability to record and replay our dreams or interact telepathically with one another via brain implants or neural cables. And you don't need a thought camera to know that most people will find these ideas fascinating. 3. Tesla valve. Nikola Tesla invented the Tesla valve. A Tesla valve, also known by its designer as a valvular conduit, is a fixed geometry passive check valve. It permits a fluid to flow preferentially in one direction while avoiding the use of moving elements. The Tesla valve is utilized in microfluidic applications and has benefits such as scalability, durability, and ease of fabrication in a variety of materials. It's also employed in microfluidics and pulse jet engines. The valve was originally designed to feed fuel into the innovative Tesla turbine, though it has been used in many high-tech applications, from fluidics to mixing. Precision steel ball bearings are used here in place of the fluid to offer a real and tactile insight into the mechanism and operation of this unique solid-state valve, producing an executive desk toy that is truly fascinating to play with. 2. Tesla's egg of Columbus. Tesla spent a terrible winter working as a ditch digger from 1886 to 1887 after being driven out of Tesla Electric Light Company with nothing except worthless shares. He persevered and was motivated to improve his concept of generating energy through spinning magnetic fields. However, Tesla recognized that he had to find a means to convince investors and supporters to comprehend the potential of his innovation. Tesla created a gadget to demonstrate the concept, an electromagnetic motor that generated the force required to spin a brass egg and stand it upright. The contraption was dubbed the Egg of Columbus by Tesla after the historical anecdote in which Christopher Columbus challenged the Spanish court and investors to stand an egg upright. When they failed, Columbus took an egg and squashed the bottom flat to keep it upright. They accused him of pulling a cheap trick, but Columbus overcame their objections by explaining that an idea can appear impossible until a smart solution is found, at which time it becomes simple. This idea was incorporated into Tesla's Egg of Columbus, which he used to illustrate his concept of alternating current power to investors. It was a stroke of genius that resulted in investment from investors Alfred S. Brown, the director of Western Union, and Charles F. Peck, a New York City attorney. 1. Tesla microscope. Most people don't associate Tesla with X-ray technology, but he began experimenting with the technology in 1894. Tesla began experimenting with radiation energy around the end of the 19th century after discovering damaged film from prior tests. The following year, Wilhelm Röntgen, a German physics professor, issued a study on X-rays. To this day, Röntgen is credited with discovering X-rays, but Tesla was not far behind. He might have even beaten Röntgen to the punch if his studio hadn't been destroyed by a fire in 1895. Nonetheless, there was no ill will between the two men. In fact, when Röntgen's study was published, Tesla sent him a letter congratulating him and giving some of the images he'd been creating. In reply, Röntgen praised him for his efforts. It's obvious that Tesla was a genius, but life was never easy for this innovative inventor. Which one was your favorite? Why don't you let us know in the comments below? Well, that's it for now. I hope you enjoyed this video. Please give us a like and let us know in the comments what you think. Check out our other videos and subscribe to be part of the fun. Click on the notification icon so you can see our new videos as soon as they're uploaded. Thank you for watching and see you next time.